In this session, we will try to uncover exception handling in Java. So to understand what is exception handling, we need to understand some definitions. First one is error. What is an error? Abnormal termination of any program is called as an error. What are the different types of errors? First one is syntax errors. The second one is logical errors. The third one is runtime errors. So what are syntax errors? Syntax errors is some mistake in the program. So the program will give warnings if you have syntax errors in the program. So you can rectify them. Then we have logical errors. Logical errors are logical mistakes in the program. We will understand this as we progress. And then runtime errors are during execution of the program, external sources, for example, some input messages which are invalid will create runtime errors. That also we'll see. Runtime errors are also called as exceptions. Handling these runtime errors is called as exception handling. So there are 5 keywords to handle exceptions in Java. The first one is try. Second one is catch. Third one is throw. Fourth one is throws. And fifth one is finally. Before we uncover each of this, we need to understand the exception hierarchy. In Java. So here I have shown the diagram of exception hierarchy in Java. So we have an object and under which we have a throwable object. And then we have 2 types of classes, which is exception and error. Exception, you have runtime, IO exception, SQL exception, AWT exception. And then under runtime exception, we have arithmetic exception, null pointer exception, and so on and so forth. And under IO exception, we have file not found and file interrupt, IO exception. And then under errors, we have virtual machine error, assertion error, exception, initialization error, IO error, AWT error, stack overflow error, out of memory error. And runtime exceptions and its subclasses and errors and its subclasses are unchecked exceptions. So we have 2 types of exceptions, which are unchecked and checked. We will explore them. And these are all unchecked exceptions. All other exceptions are checked exceptions. Now let's look at unchecked exceptions and checked exceptions. Let's look at the definitions of unchecked and checked exceptions, and then we will move on to the examples. In Java, some exceptions are raised when we are compiling the Java program. Such type of exceptions are called as checked exceptions. So let's see some example. So here I'll use a file handling object, print writer. We will uncover this in the file handling session. But for now, to create an unchecked exception, I'm using it. So print writer, and let's say abcd.text. What it does, it checks for this abcd.text file in the current working directory. And if it is not available, it will throw an exception. And for this, we need to add java.io package for file handling. Now, let me compile this. So if you see here, the Java compiler is creating an exception saying file not found. So this is a checked exception. Sorry, this is checked exception. This is unchecked exception. So these are checked exceptions. Some exceptions that are raised when we are compiling the program, we call them as checked exceptions. Let's move on to unchecked exceptions. In Java, some exceptions are not raised when we are compiling the Java program. Such type of exceptions are called as unchecked exceptions. Let's look at an example. For example, I write a system SOP statement, system out line, and try to divide 10 by 5. There is no issue with this program to give the result. So it's 2. But now, if I divide it by 0, then it compiled fine. But when I execute, I got an error saying arithmetic exception and division by 0 is not allowed. So this is called as unchecked exception. So in order to handle these kind of exceptions, we can use try catch. So try and catch keywords. It is highly recommended to handle the exceptions using try and catch. So how does the syntax look like? You will have a try block and you will have a catch block. What goes in a try block? You will have some risky code which can generate exceptions. And those exceptions we need to handle using catch block. Let's look at some example. For example, let me import Java little package and I'll create a scanner SE equal a new scanner and take the input from the user system.in. We have uncovered this long back in the previous sessions. And system out print line, I'll give a prompt for the user, say enter first number. And I'll use print println so user can enter in the same line. Then I'll assign that user entered input to an integer a. Then I'll also get another number, enter second number, and I'll assign it to b. Now what I'll do, I'll use a try catch block. Try and add some risky code here. What is that? I'll do system out print line and say division and a divided by b. And I'll write a catch block and I need to create exception object. And here I need to write the code to handle the exception. For now, what I'll do, I'll just create a SOP statement saying division by 0 is not possible. That's what I'll print to the console. So let's try to compile and execute this program. Compile fine, execute. First time I'll give first number as 10, second number as 2. I'll get the division as 5. Let me try to divide it by 0. Execute. First number is 10, second number is 0. Then it says division by 0 is not possible. So instead of program erroring out, I handled it nicely and we get the message and the user will correct the inputs. This is how we handle the exception. Now let's move on and explore various possible methods to print exception information. You can understand what this means shortly. So if you remember the diagram, we have throwable class defines the following methods: print exception information. One, print stack trace. what it prints, name of exception, description, and stack trace. And then another method, toString method. What it prints, name of exception and description, no stack trace. The next one is get message method. What it does, it's the description. Now let's look at examples for each of these methods. So in the same example, instead of, maybe I'll retain this, or maybe I'll comment it out. And then what I'll do, eobj dot print stack trace. Now let's try to compile and see what it gives us. Compile and execute. I'll enter 10, I'll enter 0. Now it says Java lang arithmetic exception divided by 0 is not allowed. So now let's try to use the next method, which is e object dot toString. I'll try to save this first. This is for print stack trace. Get rid of this, and I'll also get rid of this, and I'll paste the result here. So now this one is for toString method. File. I missed the open and close braces here. Compile and execute. Enter first number 10, second number 0. Then it just printed the name and description. I'll try to paste under toString method. Now I'll change it to get, or I'll retain this and out, and change this to get message. Forgot to compile it. Compile. Execute. The first number 10, second number 0. This time I only got the message. Now let's move on to finally block. What does finally block do? It is not recommended to take some cleanup activities inside try block, because if any exception is raised inside try block, automatically the control will transfer to the catch block. For that reason, we have to use finally block. Finally block will execute independent of exceptions. Let's look at one example. So here, if I create finally block and I just mimic some cleanup activities. So this will execute even when try is executed and also when catch is executed. Let's try to compile. I did close brace here. Compile, execute. First time I'll give valid ones, 10, 2, 5. I should use 11 here so that I'll get the cleanup activities in the next line. Compile, execute. So enter 10, 2, division is 5, and then cleanup activities. Now let's do the same thing in case of exception, where catch is executed. 10, 0, and then still cleanup activities is executed. So any cleanup activities we need to define in finally block. Now let's move on to throw keyword. So far what we have seen, if some number is divided by 0, then exception will be raised automatically. And if I do division by a valid number, then there is no exception. For example, if I wanted to divide it by the same number, you will not get any exception. But my requirement is I should not allow same number division. So if user inputs the same number, I want to create exception. So that's when we go for throw keyword. We can use throw keyword to user defined exceptions added. So let's look at some examples. For example, in the same example, what I'll do, I'll use if condition A is equal to B, then throw new exception and state that two number must not be same, something like this. To divide, then else I'll divide it. And finally, I don't need any cleanup activities. I will clear this file. I close this one. Compile, then execute. I'll enter 5, 5. And it says two numbers must not be same to divide. I'll do one more time. Compile, execute. Enter 10, 10. Two numbers must not be same to divide. So this is how we can use throw keyword to define user-defined exceptions. Let's move on to the next keyword, which is throws keyword. Throws keyword. So let's do the same file handling example. I'll use print writer PW is equal to new print writer, and I'll write to some xyz.txt. And what I'll do, I'll just write hello. And then close the connection. We will get to understand each of these in file handling. For now, for demonstrating throws keyword, I'm using this. So for using this, I need to use IO package. I'm not using throws keyword as of yet. I'll get an exception when I compile, which is expected. So now, for example, I do not want to get the exceptions in this case. So I'll just paste the exception here. So in the above program, file not found exception is reported. So in order to handle, I can use try catch manually, and programmer is responsible for handling it. The next one is throws keyword. So navigating to default exception handler by JVM. If you are anticipating any exceptions in the program and programmer didn't handle them, you can use throws keyword and define the exception object. So this way you can avoid any exceptions which you might not use try and catch to catch those. Obviously, you have to write some additional logic how to handle those exceptions, but just to demonstrate, I'm using throws exception. I will use try catch to handle the same exception, get rid of throws. Put these two lines inside try block, which is basically code, and then create a catch object, exception, obj, and here I'll write a SOP to get the message. Obj dot get message. Compile and execute. Let's summarize the exception handling. First one is try. We put some risky code here. Second one is catch. We put the handling code here. Third one is finally. We put the cleanup activities here. Fourth one is throw. Hand over our created exception object JVM, then throws. Navigate, checked exception to default exception. I will stop here and continue.